Welcome back, focused learners, to this explainer. Okay, today we are getting into some seriously cool engineering behind an innovative app called Ration. And yes, that is pronounced Ration. We're going to unpack exactly how its Copilot feature is completely redefining app interfaces by leveraging something called agentic app control and doing it all directly on Cloudflare. If you want to understand where the future of AI and structured data is actually heading, well, you are in the exact right place. So let's just jump right in. Here's our blueprint for today. We're going to start with this big UX shift into the era of agentic apps, introduce you to Ration Copilot, and then we're going straight under the hood. We'll explore the Cloudflare primitives powering the edge architecture, dive into semantic search with Vectorize, look at how they use a unified catalog via MCP, and then wrap it all up with what this means for the new interface standard.
Section 1. The era of agentic apps.
You know, the foundational problem with most AI products today is that they literally just stop at basic conversation. They leave you to do all the manual, operational, heavy lifting. And that brings us to a really clear divide. On one hand, you've got traditional chat wrappers. These are super high friction. You ask a question, you read the text it spits back, and then you still have to go do the work yourself. But on the other hand, we have this massive innovation, agentic app control. This is where the software actually takes direct, meaningful action inside the product on your behalf. It essentially turns a static chat box into a live control surface.
So what exactly is agentic app control? Well, it's basically an assistant that performs genuinely useful work within a product. It uses structured tools, verified identity, and strict safety boundaries to execute live operations. True agentic control is absolutely not just about answering your queries cleverly. It's about executing complex logic safely right within the guardrails of a well-built user interface.
Section 2. Introducing Ration Copilot.
Now, Ration, again, pronounced Ration, is honestly the perfect test case for this, because pantry management deals with highly structured, highly logistical data, and it operates on this totally closed loop. The Copilot can query what they call cargo, which is your live pantry inventory. It then matches that with the galley, which are your available recipes. It can read and schedule your manifest or weekly meal plan, and it syncs supply to generate mathematically accurate grocery lists. It even talks to you using domain language status updates, like saying checking cargo. It seamlessly handles all those annoying little handoffs between planning what to eat and actually shopping for it.
So here is how that actually plays out end to end. First, you just give it a natural language prompt, something like, hey, what can I cook with what I have? Second, Copilot instantly fires off calls to structured domain tools. Third, it queries your live household data. And fourth, it streams that action or result right back to you. By ripping through those 4 steps, Copilot literally turns a tedious logistical headache into a seamless 10-second interaction. It's a real game changer.
Section 3. The Cloudflare Edge Architecture.
All right, consider this our lead engineer whiteboard moment. Ration runs on 3 distinct Cloudflare workers. We've got the main Ration worker, which handles the React Router app and REST APIs. Then there's Ration-mcp, handling the external MCP server. And finally, Ration-Copilot, which manages that first-party WebSocket experience. But here is the massive engineering takeaway you need to catch. There is absolutely no forked business logic here. All 3 of these workers share exactly one domain model. So if the core logic improves, every single entry point benefits instantly.
Let's trace a single user prompt through this architecture so you can see it in action. Step 1. The client fetches a handshake token via the REST API. Step 2. It immediately opens a WebSocket connection directly to the Copilot worker. Step 3 is absolutely critical. It routes that connection to the conversation's durable object to establish a persistent state. And finally, step 4. Cloudflare's Project Think agent takes over and runs the multi-step tool loop so the AI can actually execute the action.
And honestly, this flow illustrates exactly why using Cloudflare's Project Think alongside durable objects is vastly superior to trying to build an AI integration codebase from scratch. It handles the state, the streaming, and the complex multi-step tool loops directly at the edge. And it does all of that without requiring extra HTTP hops back to some separate server. It is incredibly robust, and it is blisteringly fast.
Section 4. Semantic search with Vectorize.
Now, to understand how Ration handles the completely unpredictable, messy reality of human kitchen data, just look at this quote from the source material. Kitchen data is alias-heavy. Exact matching misses too much, and broad keyword matching returns too much, right? Simple keyword search just fails constantly in this context. If you log tinned tomatoes in your inventory, but the recipe specifically asks for canned tomato, a strict exact match system completely breaks down. And obviously nobody wants an AI that accidentally makes you buy 40 extra cans of tomatoes just because of a typo. We need semantics.
So how do they actually solve this? Well, first, they embed the user's query via Workers AI using a Gemma 300 million parameter model. Next, they take that and search Cloudflare Vectorize, keeping it strictly within the organization's isolated namespace. Then, they hydrate those candidate matches using their D1 database. And finally, and this is the vital part, they run strict quantity and unit compatibility checks. It's a brilliant way to achieve practical semantic matching without ever sacrificing numerical accuracy. The synergy between these two systems is crucial. Vectorize provides the semantic similarity and candidate recall. It's what beautifully catches those tinned versus canned variations. But the D1 database always remains the transactional source of truth for realistic item states, boundaries, and exact quantities. Put simply, vectors suggest the candidates, but the final decisions always have to pass deterministic business logic, so your meal planning stays mathematically sound.
Section 5. 1. Catalog via MCP.
I really want to hammer home this one-domain emphasis we talked about earlier. Ration exposes over 35 structured tools, and these are shared across both its internal Copilot and the Model Context Protocol, or MCP. This means that an external agent, like Claude or Cursor, uses the exact same logic and tool schemas as the built-in Copilot. It relies on OAuth 2.1 delegated access release privilege, it strictly enforces session identity, and it prevents unbounded write storms using robust rate limits.
Now, here is a truly wild innovation. Agent-first onboarding. This setup actually allows autonomous AI clients to self-register via an auth.md file and start operating a kitchen before a human being even signs up. At Tier 0, the AI agent does literally all the setup work, populating the pantry, matching up recipes, and then the human simply claims ownership of that account via email later on. It completely flips the traditional onboarding flow on its head.
Of course, giving AI agents write access requires some serious guardrails. You can't just let it run wild. Thankfully, that's built natively right into Ration's tool definitions. High-impact writes, like deleting data, require explicit user approval through a needs approval flag. The AI literally cannot bypass it. Copilot also deliberately declines unrelated tasks to stay tightly focused. Credit-heavy flows like image OCR stay strictly contained in the native UI. And structured error envelopes are in place to prevent the agent from hallucinating when things inevitably go wrong.
Section 6. The new interface standard.
As we wrap up this explainer, let's zoom out to the ultimate user outcome here. Why does all this edge architecture actually matter? Because in the real world, household food waste is fundamentally an information freshness problem. Ration fixes that broken data pipeline. Fast ingestion via AI vision and MCC severely limits data staleness. Semantic matching stops you from buying duplicate groceries. Computed shopping deltas keep your plans strictly aligned. And cook time deduction automatically resets the loop once a meal is made. This pipeline directly stops your food from turning into trash.
I want to conclude with this somewhat provocative thought regarding our new baseline expectation. Does your software meet users where they already are? You see, users shouldn't have to choose between a beautifully designed UI and a highly capable agentic assistant. They should get both, working completely seamlessly on a shared living domain. Think about how agentic control could redefine the tools you use every single day. Thanks for joining me on this explainer, Focus Learners. Keep exploring, stay curious, and I'll catch you next time.